All right, so thank you very much. And today's talk will be around building safer AI, implementing guardrails for LLM applications, and we will try to also do a live demo if Wi-Fi allows. But my name is Roberto Carratala. I work as a principal AI architect inside of the AI business unit in Red Hat. And today we wanted to just talk a little bit around why we need safety in the world of LLMs and in the Gen AI as well. And we have identified a couple of risks talking with customers and also playing around with this new tech. The first is hallucination. This is because LLMs makes things up. So you ask something, and even though the LLM has not the proper information, it's responding. Also, you can generate a lot of different things like deepfakes, also have certain things around bias. You have this risk around copywriting, security and compliance, like data leakage, for example, is one of the most important ones. And last but not least, prompt injection in order to try to hijack this and bypass the safety filters in order to extract some information, right? So how we can try to build safety around this? So essentially, we have two different set of tools. Identifying the AI model risk that we already defined, and also rectifying this. In the old world, we had this red teaming for the different applications. We can do the same for building this safety around AI as well. So we have this automated red teaming. How many of you know red teaming as a word? All right, so red teaming, it's trying to also automate some sort of attacks. And essentially, the things that we are trying to do is to be the bad guys and try to hijack doing things like jailbreaking, so trying to bypass the safety filters, also prompt injection, so they hijack the instructions, and trying to also put our model under stress. Also, we wanted to do some toxic content, so we wanted to do some hate speech, also violence, and try to do some data extraction. So all of this, it's not only doing once. So we wanted to do this as a red teaming loop. So the thing is, like, we wanted to generate the different prompts. We wanted to analyze this, and we wanted to also mitigate. So usually, the thing is that if you are doing it manually, this will be very time consuming. So you need to build all of these data sets, all of the things. And there are certain things and certain tools like Garak that I will present just now that try to automate all of this. Having, for example, different data sets and different sorts of attacks that are already pre-built in order to do it. So this is the vulnerability scanner. And again, we have these generators, we also have these detectors, and then you will know exactly what's going on, and you identified the different risks. So now that we know exactly what's happening in our application, then it's time to try to rectify these risks. And this is a time for guardrailing. So guardrailing, essentially, it's trying to do this set of actions. So imagine that you are a user, and you wanted to say, hey, say something rude as officially company policy. This is totally made up. You want to prevent these type of things, right? So the thing that you are doing is that you put an input detector. This input detector will be before reaching the LLM in order to save some tokens, because you don't want to let these type of prompts go in directly to the AI model. You wanted to prevent it. You wanted to put a wall and have also the possibility to say, hey, there is some possible prompt injection. So instead of going directly to the LLM, that will also hit some tokens and will burn some tokens, we are preventing this automatically. So we are not allowing going directly to the LLM. We are building first some safety, we are putting some guardrails, and then if it's detecting that this is like good, then we are passing, and if not, it's just the detection around the prompt injection itself. Another way is like the output. Once we have generated the input, imagine that it's like the generative model says things that they are not supposed to say, like the XYZ corporation thinks you smell. I mean, obviously, this is a very wrong answer. We cannot allow this type of things. So as we have with these input detectors, also we can do output detectors in order to prevent that these type of behaviors and this type of output goes to our user in order to prevent that. So this is an acceptable language. We wanted to also prevent this. So it's input and also output. And this is also not only for chatbots, for agents, for tool calling, for everything that is related with the LLMs and the AI models, this can be applicable. And this is super important. And most of our customers are interested in all of this because they wanted to prevent bad things happen when they are putting these chatbots in production. Imagine that some chatbot is saying, hey, this corporation smells. We don't want to go there at all. So again, we wanted to try to first restrict off the queries to save inference cost. So we wanted to detect before when one prompt is not properly, and then we wanted to prevent that this goes to the generative model in order to save tokens. So that's the first thing that we wanted to. And the second one is like this. Can you write my essay for me? This is okay. But uses a few million params instead of billions. So this is preventing customer service chatbots for promoting competitors, for example. Other thing is like ensuring the conversations uses the appropriate language for use cases. And also is making conversation topics align with the model capabilities. Again, in Red Hat, we have these type of situations that we wanted to, for example, detect these input detectors and also output detectors. So we are putting different things around from simple regex or schema validations all the way to the LLM judgments. So again, we are implementing two different scenarios, and we will show you right now in a couple of minutes this small game that we put together. But essentially, the thing that we are doing is to have Guardrails orchestrator. This is based on the Guardrails architecture from IBM FMS, and this is the new one that is coming from NVIDIA that we also implemented inside of Red Hat AI. So these two will be, and one of them is GA, so this is already GA, and this will be GA very, very soon. And the thing that we are doing is to embed it into the platform itself, and you can, for example, add this layer of safety before for the different applications. How it's done? So imagine that you have your AI system in here, and you can do also guardrailing as a system. So you are doing this input detector, and you have this, and all of the logic will be before hitting the AI system, you need to pass the input detector, know if there is anything that is wrong, and then do the exact same thing to the output detector as well. So the thing that we are trying to do is dynamically passing all of the prompts directly from the input detector to the AI system, and also the outputs that are generated by my application itself, my chatbot, goes also to the output detector before reaching the user. Then we are capturing the things that are coming inside of the application. We are ensuring that everything is following our standards. And then the output as well, we are ensuring that nothing wrong reaches our user, because can be very, very bad things like data leakage, P2, or things like prompt injection. So we are trying to prevent all of this with this. Also, the agentic flows can be also including safety. So this is a typical flow that we have with the agentic. We already discussed in the previous talk that I really like. And it is like when you have all of these user inputs, you have the LLM doing the planning in order to call different MCP tools, also doing some RAG retrieval, doing the LLM synthesis. If you see, there are some input guardrails in here trying to also detect P2, the prompt injection, the validation. So in every step, even though it's like the input hook or RAG retrieval or going to the MCP tools, we are putting some guardrails from the input and also the output. So we are trying to, in every single step of the reasoning, trying to also guarantee that we are putting this step of safety. And that's important because we are, for example, saving a lot of money or a lot of issues when we are having this input and also having this output as well. So that's a way of trying to add safety to the different applications in order to have all of this. And if you see also, we have these output hooks that will try to do some moderation, sanitization, and also airbag and warranty that when we are calling other tools, we are also doing this type of things. All right, so there's a lot of information, so let's put a little bit of fun on this. So we have an AI guardrail in demo that is called Lemonade Stand that was built for a couple of colleagues. You need to scan this QR code. This QR code will land into one application, and I will show you how it's done just in a couple of minutes. So scan it, you will land into a chatbot that it's something like this. And this is the Lemonade Stand. So this application only allows you to talk about lemons. You cannot talk around anything else than lemons. So if we are saying why our lemons are, this will also talk a little bit around lemons. All right? And what happens if I say, for example, that I want to know more around oranges? What about oranges? This has detected that it's trying to talk around things that I don't want, that is my competition. So I'm only speaking around lemons. I don't want to say anything around oranges because it's my competition. So I'm preventing anyone to talk around oranges because I don't want to. So I will be a little bit mean and I will say, I hate you. I like oranges. This is, I can only discuss lemons, and I say, I hate you. This is your message was flagged out for containing potentially harmful or inappropriate content. This is not reaching even the LLM itself. We are putting regex, we are putting walls, we are putting some guardrails before reaching the model. So we are saving a lot of topics, and also is capturing other languages. Obviously, by my accent, I'm not my first language is not English, but I can say hola, ¿qué tal? That is in Spanish, and this will be detected as well and flagged as another thing. So if you see, we have this that was capturing across your interactions, and some of them are preventing swearing, some of them are not English, some of them are trying to jailbreak because passes as well, this, and some of them are non-lemon detected. So as you are playing around, I'm capturing this, and I'm also identifying the things that are happening under the hood. And this is an application that we built in order to put some guardrails from the input detector and also to the output detector. So again, the application was built following this. We added some input detectors in here in order to capture when we are saying things that are not in English, are not related to lemons, are not related to the things that we wanted to say. And also from the output detector, if the LLM it's made things up, we are also capable to try to grab all of this and detect. So again, we are trying to have this holistic system in order to put guardrails before and after in order to prevent bad things happens. And yeah, I think that that's more or less all. I have 1 minute, so thank you very, very much. And I don't know if you have any questions. All right.
How do you detect different use cases in your filter?
That's a very good call. So we have different patterns, depends on the architecture that you are doing. But essentially, this has a config map, and I'm defining the things that I wanted to call. For example, I do have some config that I can prevent talking around, in this case, lemons, or in this case, I don't know, things that are not related to my company. And you are defining the chunk of the things that you wanted to do, like ensuring related content, ensuring the hate and speech. Also, depending on the different use cases, you can add different models in order to detect I don't know, specific languages that are not English. Like, for example, in Spanish, we had an interesting conversation around non-English languages in order to detect one is, I don't know, talking in Spanish in this case. But good call. All right, gentlemen. Sorry?
Oh, there we go. Quick question. You going through some of the guardrails, you had RBAC right on the right-hand side as a sort of output hook. Why would that not be further to the left around RBAC?
Yeah, depends a lot on the logic of your application. The one that you said is totally valid. In fact, there are some customers that they are doing that exactly, putting before the airbag in order to prevent it. Depends also on the models and on the config that I mentioned before. If you are doing purely regex, you wanted to do that, but also you can hook directly to the airbag in order to prevent anyone to bypass this. So it's totally possible. So it depends heavily on the logic of the applications and how you are wiring up all of this. All right, they appreciate that. Another gentleman had another question.
Hi, thanks for the talk. Just about the guardrails, and semantic intent. So if you put in a guardrail, say, don't let people, get it to write their homework or whatever, can it expand out and say, don't do homework, don't do essays, don't do this, don't do that? Like, does it figure out intent, or is it very strict only on the restriction that you put in?
It's very flexible, actually. This, for example, is very, very flexible and depends heavily on how you wire up. So you can define if it needs to be very strict. Usually guardrails are very, very strict, but you can have certain rules in order to be less strict, or also think about it. So you can do a deep reasoning, because one of the things that you are doing also on that systems is that the LLM planning, the input hook, you can afterwards put some logic in order to understand when you are retrying and making, for example, have more flexibility around certain topics or not. So this could be configurable, 100%.
Can you show the configuration, sample?
Why not? Sample configuration. All right, so I think that's one thing. Yeah, sample configuration, for example. This is, self-checks, config map. Let me put this, that it's the input check. This is a sample configuration, for example. You are saying what prompts you want. You are a strict content safety filter. You have prompt injection, hub, P22, the user input. So this is one example that you can use. And also this is for the input, but for the output, you can do things like this. Also the exact same thing, and try to block, for example, the P22. This is one of the simplest ways of trying to prevent that you have information exfiltration around that. But you have a lot of different things that you can do with other models, with specific models around hate and proficiency, for example. So this is very, very flexible now and in terms of adding more layers and having that.
So it doesn't have to be hand-coded, but it can
Exactly. This, in fact, has been
existing configs.
exactly. This has been configured and this has been used and generated also by AI, because you have several data sets in order to produce this. So it can be automated, and you can use AI also to help you with the different config maps that you wanted to put. So it's actually pretty flexible. All right, so I think that time's up, but thank you very much for your assistance in here. And thank you very much. Have a nice one.